IB Oxford ASL exercise 11E. The topic is still trigonometry, geometry and trigonometry. Question 1, find the area of each triangle. So at this point, we have so many methods of finding the area of a triangle, but we are going to use, because we have two sides and an included angle, we are going to use the formula for area is given by half product of the two sides and then multiply by the sine of angle between them. So for A, we'll have half multiplied by 8 times 6 multiplied by sine of the angle between them. So you're going to use your GDC to multiply half times 8 times 6 times sine 80. So that's quite direct, and we should get an answer of 23.6 square centimeters. Part B, 1B, the same formula, half times the two sides times the sine of angle in between them. So use your GDC to do that, and then you'll get an answer to the significant figure 61.4 square centimeters. Number C, the same thing we'll do here. Half multiplied by the two sides multiplied by the sine of angle in between them. Use your GDC and you'll get your area as 2.73 square centimeters. For number D, we'll do half multiplied by 7 times 4 times sine of angle between them. Do this using my GDC and you'll get your answer as 13.9 square centimeters to three significant figures. Part E, you have two sides, but there's no angle in between them. But we have the property of a triangle that all the angles will add up to 180 degrees. That means if we subtract the already given angle from 180, we'll be able to get the missing angle. So 40 plus 80 from 180, that should be 60 degrees. So the angle between these two lines or two measurements is 60 degrees. So you can comfortably use the formula half times A times B. So the two sides times sine of angle between them. So you'll use your GDC to do half times 20 times 12 times sine of the 60, and you're going to get your answer as 104. Three significant figures, square centimeters. So this is part E. Part F. So part F, you have two sides, but you don't have an angle in between them. So you are going to subtract the sum of the two angles given already for you to use the angle in between them. And if you do 78 plus 60, that is 138. You subtract 138 from 180, you'll be able to get 42 degrees, which is the angle between those two given measurements. So you're going to comfortably use the formula half multiplied by 14 times 18 times sine of 42 degrees. You'll do this and you'll get your area as 84.3 square centimeters to three significant figures. Part G. You have two sides, no angle between them, but you can use the property of a triangle that all the angles add up to 180. You add the two given angles and you subtract from 180. So 180 minus 97, you get 83 degrees. So 83 degrees here. Then you're going to use the formula half multiplied by A times B, or 12 times 8 multiplied by sine 83 degrees. So you'll get your area. If you use your GDC, your area here should be 47.6 square centimeters. That is question 1. Let's go to question 2. Find the area of a triangle with two sides that measure 5 centimeters and 8 centimeters and include an angle of 39. So let's say this is a triangle. This formula is essential where you don't have a right angle triangle. So if this is 8 centimeters and this is if this is 5 centimeters and this is 8 centimeters, and you have an included angle of 39 degrees, you can comfortably use the formula half 5 times 8 times sine 39 degrees. Do this using a calculator and you will get your answer 12.6 square centimeters. We'll go to part B, which says in a triangle ABC, let me just draw that. In a triangle ABC, A is 8 centimeters. A is always the side which is opposite to the angle A. So this is A, is 8 centimeters. B is also 8 centimeters. So the side which is opposite to angle B is the side B, 8 centimeters. And the area of the triangle ABC is 16 square centimeters. So find the measure of angle C. So angle C here. So remember, angle C is the angle between those two given sides. So you can comfortably use the formula and say area is equals to half multiplied by A times B times sine C. Okay, so we are going to simplify this by 2, 1 by 2, 4, such that we'll have our sine C being equal to 16 divided by, we are going to divide 4 times 8, which is 32. So for you to get C, you need to do sine inverse on both sides. So 16 divided by 32 is half. So sine inverse of half should be 30 degrees. Okay. So angle C is 30 degrees, and you should not use a calculator here. They have indicated we just used analytical or algebra to do that. And then to number 3, find the area of this parallelogram. So because this is a whole parallelogram, you're going to divide it into 2. For visualization, you'll see that we'll have 2 triangles, and those 2 triangles are similar. So we're just going to find the area of one triangle and then we multiply by 2. So we're going to multiply the area of one triangle by 2, half 2 sides times sine 60 degrees, the angle between them. You'll notice that these two will cancel, and then you're going to do 20 times 12 times sine of 60. You're going to use your GDC and you'll get your answers 208 square centimeters, because it will be 20 times 12, that's 240, multiplied by root 3 over 2, which is sine 60. That's number 3. Number 4, find the surface area of tetrahedron ABCD when all of the faces are equilateral triangles with the side length 10 centimeters. So we have all these triangles being equilateral and they measure side 10 centimeters. So for an equilateral triangle, one property is all the angles will be 60 degrees. For example, if I take the base, I'll have 60, 60, 60, and then I'll have 10, and also all the sides are equal. So I can calculate the area of triangle ABC, and because all the triangles are similar, when we have triangle ABC, we also have triangle BCD, we have triangle ABD, and we have triangle ACD. So those are the four triangles we have. So we get the area of one triangle and then we multiply by 4. So 4 times the area of one triangle, half times 10 times 10, then the angle between them, which is sine 60 degrees. So use your calculator. If you use your calculator to do that, you should be able to get your answer as 173 square centimeters. All right, so that's number 4. Number 5 is down here. We have a regular pentagon, 5-sided. Sorry. Find the area of a regular pentagon of radius 4 meters. All right, so a pentagon will have 5 sides, and if we are to join uh, these lines, called the apothem, you'll notice that we'll have 1, 2, 3, 4, 5 triangles. The angle at the center is 360 degrees, but it is divided equally into 5. So 360 divided by 5, you'll get that one angle is 72 degrees. So we can comfortably say that one triangle will have an angle of 72 degrees and a side of 4 and 4. So we can calculate the area for one triangle and multiply by 5 because they are 5. So 5 times half times 4 times 4 times sine 72 degrees. You'll use your GDC to do this and you should obtain your answers 38.0 squared centimeter. So 3 significant figures. Lastly, number 6, find the value of x when the area of this triangle is 5 root 3. So we'll use the same formula. Area is given by half times 1 over the side times the other side times sine of the angle between them, which is sine 60 degrees. So I'm going to rewrite that sine 60 degrees according to the special triangle. So sine 60 degrees should be, so if this was the one side of the triangle, this is root 3, this is 2, this is 1, this is 60 degrees. So sine 60 is root 3 over 2, opposite over adjacent. I mean over hypotenuse, sorry. Opposite over hypotenuse. All right, so we are going to rearrange. So we're going to get rid of 3 over 2 and half by dividing both sides by that. And that should, let's start with half. So we'll multiply both sides by half. So our left-hand side will be 2 times root 3. 2 times 5 times root 3, which is 10 root 3. And then I can write what is on the right-hand side. And then we are going to divide both sides by root 3 over 2, which is the same as multiplying both sides by 2 root 3. So if we multiply 2 divided by root 3 on the left-hand side times that is equals to x plus 2 to x plus 1 root 3 over 2. So we are saying we're multiplying both sides by the reciprocal for us to get rid of this. So we multiply both sides by that. Root 3 will cancel with root 3 here. We'll only have 20 on the left-hand side. And then you can open the bracket here. You will get, this is x times 2x is 2x squared. And x times x is x. And 2 times 2x is 4x. So in total, there will be 5x. And then 2 times 1 is 2. These are quadratic. You can bring 20 to that side so that you have your equation in terms of ax squared plus bx plus c is equals to 0. So if you bring 20 to that side, it will be 2 minus 20, which is minus 18, goes to 0. So remember here we're talking about length. So we should keep in mind even when we are solving this quadratic that we should have a positive x. So we can say x is greater than 0. Before we solve for x, I can use the quadratic formula, or you can use any formula you prefer to solve this. I can use the quadratic method or quadratic formula, which is x is equals to minus b plus or minus square root of b squared minus 4 times a times c divided by 2a, 2 times 2. So x here will be minus 5 plus or minus. This is 25 minus 4 times 2 is 8. 8 times negative 18 should be negative 144. So that inside the bracket we'll have 25 minus negative 144 divided by 2 times 2 is 4. So that x is minus 5 plus or minus square root of 25 minus 144 is 169 divided by 4. So this will be the same as minus 5 plus or minus square root of 169 is 13. Remember here, you're not supposed to use the GDC. You are supposed to use the analytical way. One of the ways to be organized is to ensure the equal sign is in one line. So minus 5 plus or minus 13 divided by 4. So again, since x is greater than 0, we are going to take the positive. Minus 5 plus 13 divided by 4. And this will surely give us an answer of minus 5 plus 13 is 8 divided by 4 is 2. So the value of x is 2. So if you have that value of x as 2, you're going to get, or you solved what they want. See you in the next meeting.